Chapter 8, we looked at higher degree polynomials. So some of the questions looked like this. Given this function, is it even or odd? Is the lead coefficient positive or negative? What's the degree? What's the end behavior, we call it? So let's take a look at this first one. Make this a little bit smaller. All right, so I know this is an odd function. It's the bendy straw function where the end behavior ends differently. So we're going to say that this is an odd function. The lead coefficient would be negative because you're spitting out of the straw. So you start up and then it goes down. The degree, let's count the number of zeros. 1, 2, 3, 4. Has 4 zeros, so the degree could be degree 5. And then the left-hand behavior, as you go to the left, what's happening? It's increasing. And then the right-hand behavior, as you go to the right, what's happening? We would say it's decreasing. All right, let's try the next one. It ends, it's a field goal function. They both end up, so this is an even function. The lead coefficient is positive because they end both going up. The degree, let's count the number of zeros. 1, 2, 3. Or the number of turning points, not zeros. So they should have been turning points over here as well. So there's 3 turning points, so the degree is 4. Let's put this 4 here. The left-hand behavior, as you go to the left, what's happening to the graph? Your graph is increasing. The right-hand behavior, as you go to the right, what's happening? It's also increasing. So I'll put right hand is also increasing. My Mobi is dying here. Increasing. So we looked at these characteristics of a graph of a higher degree polynomial. All right, let's try this one. So using the polynomial right here, f of x, explain how the degree and the leading coefficient will affect the end behavior. All right, so the degree is 7. So we know that that is a bendy straw. And it is negative. So we know that it's a bendy straw and you would be spitting out of the straw. So bendy straw down. Liam was practicing his drive in a dome over the winter. He hit the ball from the top of the dome, from the top level of the dome. The height over time is given by this equation. For what interval of time is the height of the ball greater than or equal to 156 feet? All right, so let's make this into an inequality. 16t squared plus 100t plus 20. We want to know when is that greater than or equal to 156. Okay, so to solve this, we could graph. We could use quadratic equation. We could try to factor it. But before we do that, we need 0 on one side. So I'm going to subtract 156 from each side. So we have 16t squared plus 100t, and 20 minus 56 is negative 136. We want to know when that's greater than or equal to 0. So again, your steps are, you could try to factor this and use zero property. You could try quadratic formula, plug it in, get your zeros. Or you could try graphing. I'll try graphing. So I'll go here, tab, type in our function. All right, we got 16 x squared, so you have to change your t to an x, plus 100x minus 136. All right, we're looking for the x-intercepts, which we can see right here. You can zoom out too if you want to see the whole graph. You can see the whole graph here. You would see the zeros. I'm going to zoom in actually. Let's try zoom fit, see what happens. Oh, it doesn't look too good either. Fine, we'll zoom back in. We were really looking for the zeros, not the vertex, so zoom in again. All right, so menu, analyze, graph. Let's find our zeros. We know it's not the negative one. We're just looking for the positive one. So at 1.15, so we have t equals 1.15 seconds. And actually, we do need the other one too, don't we? Why is it negative? It shouldn't be negative because, again, here's the picture of what it would look like. You hit it from the top of the dome, it's going to go up and then down. And we're looking for these two right here, although they're shifted. Okay, let's use quadratic formula since my graph. I probably typed something in incorrectly. Let's double check my graph. Tab. Oh, I see what I did wrong here. This should be a negative. I forgot that little negative right there. So let's put that in. Now let's find the zeros. This makes more sense now. Okay, now we have two positive answers. Let us find what they are. Analyze graph, the zeros. So one is at 2, and the other one is at 4.25. That makes much more sense. So we're going to say between 2 seconds and 4.25 seconds. That ball is greater than or equal to 156 feet. Okay, so now you're going to practice these same types of problems for Chapter 8. And then if you have questions, you can let me know in class.